Hello everybody, this is Mr. Navarrete, and today I'll be going over the Chateliers Principles Homework. So, let's get started. For question 1, it gives us the following reaction, and it asks us to predict the direction of the equilibrium shift. Now, the way I like to look at these problems is like a seesaw, telling me what direction my reaction is going to go to. One new thing that we have added is this reversible symbol, meaning that we can go forwards or backwards in the reaction, depending on which one we have more of. So let's look at our first little section. It says we want to figure out the equilibrium shift if we add oxygen. Oxygen here is a reactant. So looking at my seesaw, I'm adding reactants. My reactants are going to go up. And this lets me know, since I increase the amount of oxygen, that my reaction is going to go towards my product. It's going to go to the right. B asks, what if we remove HCl? Looking at my seesaw, I am going to be losing HCl. It's going to go down. Thinking of the direction that my reaction is going to go to, it's going to go towards my reactants. It's going to go to the left. See, well, what if we add water? So now water is on our products. We're going to be increasing our products. That part of my seesaw is going to be going up. And that tells me that my reaction is going to go towards my reactants. It's going to go to the left. Lastly, if we remove CO2, CO2 is in our products, so that means my products are going to go down. Looking at my seesaw, it's going to go down, and that's telling me that my reaction is going to go towards my products. My reaction is going to end up going to the right. I'll keep the seesaw for the next couple of problems, so feel free to use it. For 2, we're going to look at the decomposition reaction of hydrogen iodide into hydrogen gas and iodide. Let's predict the direction of each of the equilibrium shifts. If we add hydrogen iodide, we're going to be adding reactants. So that means my seesaw would go towards my products. It's going to go to the right. If we remove hydrogen iodide, my reactant side is going to go down. So my seesaw tells me that my reaction is going to go towards my reactants. It's going to go to the left. If I add hydrogen gas, I am adding products. My seesaw is going to go towards my reactants, so my reaction is going to go to the left. Lastly, if I remove iodide, my products are going to go down. My seesaw tells me that my reaction is going to go towards my products, so my reaction is going to go to the right. For 3, we're given the following reaction, and we want to predict the direction of the equilibrium shifts. Our seesaw might be useful. Let's use everything that we've learned in the prior units and apply it here. For A, it says our pressure is increased. That means we are increasing the number of collisions. On our reactant side, we have 4 moles of hydrochloric acid and 1 mole of oxygen gas, 5 moles in total. On our products, we have 2 moles of water and 2 moles of chloride, 4 moles in total. Which one has more moles? Our reactants have more moles. So that means if we increase the pressure, we're going to increase their number of collisions, causing our reaction to go to the right. The more collisions, the more products we can make. B asks, what if we add energy? On our reaction, we have our energy or heat on our product side. If we increase the amount of energy we have, we're going to send our reaction towards our reactants. It's going to go to the left. See, if we increase the volume, we're allowing a larger number of moles to take up that volume. As previously mentioned, our reactants have 5 moles in total. If we increase our volume, we're going to allow for more of those to take place. So that means our reaction is going to shift to the left. D, if we place it in an ice bath, that means we are lowering our temperature. We are lowering our energy. If we lower our products, going back to our seesaw, we're going to send our reaction towards our products. It's going to go to the right. 4 gives us a reaction of how methanol is manufactured. And again, we're going to predict the direction our equilibrium will shift. A, if we decrease the temperature, again, we're going to be decreasing the energy. If we are lowering our product side, that means our seesaw would go towards the left. Our reaction is going to head towards the direction of our products. B, if we increase our pressure on our reactant side, we have 3 moles in total. On our products, we only have 1. Higher pressure, more collisions, and the one that benefits the most from that are our reactants. And as a result, our reaction is going to go to the right, towards our products. C, if we add hydrogen gas, again, we are going to be increasing our reactants. That means it's going to send our reaction towards our product, so our equilibrium would shift to the right. Lastly, if we add a catalyst, catalyst only affects our activation energy. It's not going to tell us what direction our equilibrium is going to shift. In this case, adding a catalyst would have no effect. 5, we're given the following reaction. Let's predict the shifts in equilibrium. If we add oxygen, we are increasing our number of reactants, sending our reaction to the right. If we add energy, we are increasing our products. If we increase our products, we're going to be sending our reaction to the left. If we remove nitrogen monoxide, we are lowering our reactants. That means our reaction is going to go to the left. If we add a catalyst, it's not going to do anything. All it does is lower our activation energy. So it would have no effect. Still on 5, now it asks what happens when we place it in an ice bath. If we place it in an ice bath, we are lowering our temperature, lowering our energy. If we decrease our products, we're going to send our reaction to the right. If we increase our volume, on our reactants we have 3 moles, products we only have 2, our reaction would shift towards the right as we have a larger space to hold all of these moles. If we remove oxygen, again, we are lowering our reactants, so we are going to be sending our reaction to the left. If we add nitrogen dioxide, we are increasing our products, again, sending our reaction to the left. For 6, we're given the following reaction, and we want to see what happens to the concentration of nitrogen dioxide. If we increase our pressure, on our reactants, we only have 1 mole, products we have 2. Higher pressure means more collisions, so our reaction is going to shift to the left. What does that mean for our concentration of nitrogen dioxide? Well, if it's going to the left, that means our nitrogen dioxide is going to be used up. So our concentration will decrease. If we increase our temperature, again, we're going to be increasing our reactants. Our reaction is going to go towards the right, so we're going to be creating more nitrogen dioxide. Our concentration will increase. If we add a catalyst, it's not going to do anything. There's going to be no change as it's only affecting our activation energy. If we decrease our pressure, we are lowering the number of collisions, so our NO2 will not be used up as readily, so our concentration will increase. If we increase our volume, we are allowing for more NO2 to be made, so our concentration will increase. If we remove N2O4, we are lowering our reactants. Our concentration is going to go towards our reactants. We're going to use up our NO2, so our concentration will decrease. If we add NO2, we are increasing our products, meaning our reaction is going to go towards our reactants. Adding NO2 will decrease our NO2 concentration. And lastly, if we add helium, well, helium has nothing to do in this reaction, so if we add it, there'd be no change. Lastly, it says to suggest 4 ways to increase the concentration of sulfur trioxide in the following reaction. Sulfur trioxide is in my products, so that means if I increase my reactants, if I increase and add sulfur dioxide or oxygen, I'm going to produce more sulfur trioxide. Looking at the number of moles that I have 2 moles of sulfur dioxide and 1 mole of oxygen gas. And that's going to make 2 moles of sulfur trioxide. If I increase my pressure, I increase the number of collisions that they have, increasing my sulfur trioxide concentration. Sticking with the idea of moles, I have 3 moles and 2 moles here. If I decrease my volume, I want to lower the amount of moles present in that volume. 2 moles is less than 3 moles, so my reaction will make more sulfur trioxide. Lastly, I see that my energy is on my product side. So if I place it in an ice bath, or lower my temperature, my products are going to go down. It'll shift my reaction to the right, increasing my concentration of sulfur trioxide. And that's it. If you have any questions, don't forget to message myself or Mr. Morgan on Schoology. Other than that, stay safe, and I'll catch y'all next time.